Hey all, welcome to ShareTrek. This is Raj here. You're watching episode number 6 of the mini-series that we started on human immune systems with the aim to understand how HIV works and also to review all the various therapies and vaccines that are available right now so that we can keep track of what's happening in the field of therapeutics and how quickly we can get either a functional or a sterilizing cure. So this is episode 6. Every Friday I release a video. And the next 2 episodes will showcase new HIV therapies and vaccines either approved recently or about to enter clinical trials. Wait until the end and I will disclose which are those therapies that I'm talking about. And if you have not yet subscribed so far, I would suggest that you subscribe and press the notify button so that you do not miss any of the episodes that I release in this channel. That said, let's get started. Well, friends, in our initial videos, we had seen how the human DNA is formed, and we had looked at the fact that DNA is composed of nucleotides. There are 4 types of nucleotides in there, and they're all kept close together with hydrogen bonds. And the backbone is made of phosphate and sugar. And when the cell is formed, the nucleus contains the DNA. And whenever the cell experiences any kind of stress, it responds to the stress by asking the DNA to create mRNA. And that process produces something called as mRNA, which is a copy of some portions of the genes of the DNA. And when the mRNA comes out of the nucleus and into the cell, the tRNA and the ribosomal RNA decrypt them and assemble the amino acids and create the protein whose recipe is contained in the mRNA. So this is how the human genomic system works. And the problem we have with HIV is that HIV is a retrovirus. We had also heard about retroviruses, and I have made a video in the past in which I spoke about our DNA being 8% retroviruses. So the difference between a regular virus and a retrovirus is that the regular virus comes into the body, goes through the cycle, and then it goes away. Whereas the retrovirus integrates into the human DNA, and if it did integrate into human DNA in a portion that are replicable, then it can be passed on through the next generations. And that's how 8% of our DNA right now is remnants of retroviruses. And HIV is also a retrovirus. Some retroviruses leave beneficial functions in our DNA. But HIV is a very nasty kind of a virus, and that's the reason why we are looking at therapies to eradicate HIV. So if we were to say that HIV is a bad retrovirus, it's not only limited to the fact that it integrates itself into the human DNA, but also it uses some mysterious methods to go dormant and hide in reservoirs and to resurface from dormancy from time to time. And that makes it very difficult to totally sterilize HIV out of the body. Many therapies currently available, as well as modern therapies in clinical trials and in the research labs, are functional cures. And they are functional cures because while they can kill all active HIV copies in the body, they cannot see the dormant HIV copies that hide in various HIV reservoirs in the body. So once the functional cure has finished giving its effect, then the dominant copies get revived through some mysterious methods, and it repopulates the body with copies of HIV, which go and attack the CD4 cell and compromise the immunity. Last week, we saw AGT103-T and how it protects the CD4 cell and thus performs a functional cure with the potential to be a sterilizing cure. Today, we are going to talk about EBT101. Excision Bio has developed a platform to analyze off-target effects of CRISPR-Cas9 edits and has integrated computational methods to design the most effective guide RNAs. If you recollect from our earlier discussions around CRISPR-Cas9, one of the major problems for CRISPR-Cas9 is that it's a big molecule, and the second thing is off-base edits. and it does a double-strand break, which again has been related to some bad effects, and that's the reason why base editing and prime editing are now taking more prominence. But coming back to the EBT 101 therapy, Excision Bio has taken efforts to make sure that off-base edits are minimized and avoided, and the guide RNA created by their platform is much more effective and efficient and accurate. The function of the guide RNA is to anchor to the designated target on the DNA and allow the CRISPR-Cas9 to do its job of editing that location. The Excision Bio therapy for HIV is called EBT 101, and it uses dual guide RNAs and CRISPR-Cas9 to clip HIV in multiple places and excise large chunks of HIV DNA and thus prevent it from surviving and replicating. This therapy has performed very well on primates, and hence it's undergoing safety and tolerance tests in FDA clinical trials. It's in phase 1 clinical trial right now and on the verge of going into phase 2. Not much information is available about this therapy because Excision Bio is a private company, and unlike listed companies like we have CRISPR Therapeutics and Beam, which report every quarter, and during their earnings release they give us a little bit of a update on how their therapy is progressing. Excision is a private company, and it doesn't have any obligations to disclose those information. And from the FDA website, we can get only limited information that is available. It's more of a historical information. Latest updates are likely to be within Excision. I've reached many times to various people in Excision, but I have not got a response so far. However, once I get a opportunity to talk to them, I can bring you more up-to-date information. EBT 101 is also a functional cure. The reason being, it may not be able to see all the hidden HIV copies and hence cannot perform the role of sterilizing cure. Some of our subscribers had speculated that if EBT 101 and AGT 103 were combined, then it would take out HIV. Having looked at the mechanisms of both the therapies, I think this is not a logical solution, and here are a few reasons why. Point number 1, AGT103 is focused on protecting the CD4 T cell and thus give more time for the adaptive immunity to defeat HIV, while EBT101 aims to excise large chunks of HIV from infected cells and thus deactivate HIV. Both operate differently. Assuming both therapies are approved and available, combined cost of both therapies would be exorbitant in my opinion. And finally, if for some reason we want to combine both of them and we want to reclaim compromised CD4 T cells, then FDA will potentially, I'm not sure about this, but I think FDA will require doing clinical trials with both the therapies with various dosage levels before such a use can be approved. Even after doing all that, as long as we cannot flush out every last copy of hidden and dormant HIV, we'll end up only with a functional cure. And that's the reason why I'm thinking that, using all these therapies together, it's like thinking about Marvel and DC comics, like we put Batman, Superman, everybody together to defeat an enemy, like fantasy football. But practically, I think from a monetary perspective and from the logistics perspective, I don't think it's a practical approach. And now, before I end this video, I want to address some of our viewers who are disappointed with lack of sterilizing cure and the delay in getting AGT103 or EBT101 approved. Please consider that it takes time to tackle this complicated virus, and scientists are working really hard, and FDA has its job cut out. FDA is ultimately responsible for what happens after it approves a therapy for use among people across the world. FDA will do its job as a gatekeeper. It will take as long as it needs in order to demonstrate safety and efficacy. So we have to bear and have patience. That's what I would suggest. Second point is that ART therapy that is now helping most live a normal life is similar to what AGT103 and 101 will deliver, but AGT103 and EBT101 are the next level, because this improvement will prevent one from having to take ART on a daily basis. So it may either be once in every 6 months or once in a year injections. So that's what I think it's likely to be for these therapies. And that will be a major improvement over and above ART. And before ART came, people were really desperate for something at all that could prolong life and give quality of life. So ART has already answered the fundamental requirement. And any therapy that comes after this is going to be an improvement on top of it. One of our subscribers has been repeatedly requesting for some cure from Thailand. I have not found any reliable literature on that topic in order to do a video. And unless I find entries on FDA or some reliable science journal, I would not be doing a video in this channel. Next week, I'll be talking about Sunlenca from Gilead, which was recently approved. And I'm also in the process of studying the information on that so that I could make a video. So hold on for that. I'm aiming to bring it for next Friday. The week after that, the Friday after that, I will do a feature on Professor Ramarao of Emory University in Atlanta, who has demonstrated a HIV vaccine that has worked very well on simians and is currently preparing to enter phase 1 of clinical trials on humans. And I'm still working on the back channel to talk to Tel Aviv University team, which is coming up with a HIV vaccine. The work is ongoing. I'll let you know if I make any progress in establishing contact with someone with whom I can do an interview and get more information on the Tel Aviv vaccine to you. If that happens, that will probably be 3 Fridays from now. So with that said, I would like to bring this episode to an end. Thanks and have a great day. Bye for now.